Okay, good day. Today we'll be solving polynomial equations. Basically you have to factor it, and you apply the zero product property. Now we have 3x to the fourth power minus 75x to the second power equals 0. So since x is to the fourth power, you're looking for 4 answers right here. Okay, whatever degree it's to. Now you're going to be equal to 0 on all these, so you forget about the 0 and you go to factoring. Okay, so there's 2 terms. If I have to factor 2 terms, it's GCF, DOPS, and then all problems need a DOPS check at the end. DOPS stands for difference of perfect squares, so I go GCF, then make a nice second box, DOPS, question mark. We do DOPS plus minus. It's right there for you. Okay, so GCF, you check for 3 things, and you don't look at the 0, you're just over here. You check your last term for an x, it's there, x to the second. You check your first term for a negative, there is none. Then 3 and 75 on your multiplication chart, those are both in row 3. So I parenthesize that, and I put that down here. Okay. So then I go up here and divide by 3x to the second power. So I divide 3 and 3, that's 1. Then x to the fourth, x to the second, I minus the exponents, it's x to the second. 75 divided by 3 is 25, and the x second cancels, and you just don't put x. Okay, now DOPS. And by the way, here's one thing I would recommend. After you get these 2 parentheses, cross out your GCF. We've already placed that down here. So we're looking at this. We have a minus, okay? We don't really need to worry about the 1. And are these perfect squares? Yeah, x to the second is x times x, and 25 is 5 times 5. So we go x5, x5, and now bring those over for a DOPS check. Okay. Well, the plus can't be factored. Okay. That automatically drops. Now this is a difference, but x doesn't have a power, so NA, that means that's prime as well. Now you put equals 0 behind it now, since you're solving. Now you apply the zero product property. Now, since this x is to the second power, we're going to get 2 answers from that factor. That's x to the first, so that would be 1 answer, and that's x to the first, so that would be 1 answer. That would be a total of 4 answers. Now I take that 3x to the second power, set it equal to 0. So you divide by 3. 0 divided by 3 is 0. Then I apply a square root. Now the square root of 0 is 0. Now when you square root 0, that means 2 of the answers are 0. Okay? 2 of the answers. Okay, then x plus 5 equals 0. Okay, minus 5, I get negative 5. I don't need to square root because there's no second power. X minus 5 equals 0. I add 5, and that's positive 5. So 0, 0, 5, negative 5. So when you apply a root to the 0, a square root, a second power, that means 2 of the answers will be zeros. You'll have 0 as a multiplicity of 2. Okay, next problem, 2x to the power of 4 minus 13x to the power of 2 minus 45 equals 0. So x is to the fourth, so there will be 4 roots for us to find, 4 answers. When I say roots, that means answers. So the 0 I don't look at, I'm looking over here. Now that's a 3 term, that's a trinomial. So with trinomials, you go GCF in the table, and then there. So GCF and the table. Okay, so do an x check on your last term, it's not there. Do a negative check on your first term, it's not there. 2, 13, and 45 is just 1. So all I could find was 1, so I cross it out. Now I use ABC for my table, and we find the AC product. So 2 times negative 45 is negative 90, so it's a positive times a negative, and we have to add the factors to get negative 13. 1 and 90 is not even close. So put positive, negative again. Divide by 2, I get 45. That's not even close. 90 divided by 3 is 30. Not even close. 4 is a decimal. Then if I divide 90 by 5, I get 18. There it is. 5 plus negative 18 is negative 13. Now, off the T-chart, here's what I want you to do. Just set up 4 parentheses every time. Just do it, okay? Now I'm going to repeat this 3 times. You know you got plus 5 and minus 18, because I'm tired of people screwing this part up right here. On your A term, you have a 2. You don't break that up. You drop 2. Then you break up your x to the 4th. You drop the coefficient, but you break up the x and its power. X second, x second. Then divide. 2 and 5 can't be divided. It's only in the first row. So that says 2x squared plus 5. 2 and 18 are both in row 2, so we divide each of these by 2, and that's going to be 1x to the second minus 9. Okay? So drop the leading coefficient, 2, 2, but you split the variable. Okay, now bring those over here and let's do a dots check. So 2x squared plus 5, then 1x to the second power minus 9. First parentheses has a, by the way, you can drop the 1, you can't drop the 2. The one with a plus is circled, okay? That's prime, that can never be factored. One with a minus, well, are these perfect squares? Well, yeah, that's x times x, that's 3 times 3, so that goes. Okay, so I've got x plus, and by the way, those can't be done anymore. That's circled, that's prime. And the minus is there, but that x without a power is an NA, so that's dropped as well. Okay, so we have 2x to the second power plus 5. By the way, 2 answers come from there because the x is to the second. 1 answer from here, 1 answer from there. So that'll make 4 total answers. So 2x to the second power plus 5 equals 0. So I minus 5, and I get negative 5. Then I divide by 2. That's a decimal, so I'm just going to leave it as a fraction, but we still have the second power. So we need to cancel out the second power and apply a square root to the other side. Now when I have a negative under a square root, I have to poke the I out. Now, are 5 and 2 perfect squares, numbers that square root nicely? Look at the board. I don't think they are. So all I do is I leave the square root on. I put I square root 5 over 2. And then I put the same thing with a negative sign. And that's how I get the 2 answers. Now, x plus 3. That's easy. You just subtract 3. It's the only operation you got. So negative 3. And then x minus 3 equals 0. So plus 3 plus 3. I get positive 3. So there's the 4 roots. I square root 5 over 2, negative I square root 5 over 2, and then 3 and negative 3. Okay, next problem. 2x to the 5th power minus 162x equals 0. So now x is to the 5th, so there's 5 roots we need to find. 5. So we have 2 terms again, so 2 terms, we're back to the GCF. Use that sheet I gave you, and then you set up your dots, difference of perfect squares. Plus, minus. So you check your last term in the binomial, it has x. You check your first term for a negative, it's not there. 2 and 162, guys, they're both even numbers, so I think they will divide by 2. So I place 2x right there. Then I go divide by 2x. 2 divided by 2 is 1. Remember, that's x to the 5th divided by x to the 1st, which would be x to the 4th. 162 divided by 2 is 81. And then x to the 1st cancels. Now, When doing the dots, take that out. You've already placed that. Okay. Now, if the x has a 1 as a coefficient, it can be dropped. So we have a minus. So it's a difference. Are these perfect squares? Well, x to the fourth is x second times x second. 81 up on the board is 9 times 9. You don't divide that by 2. Look at the board. Square root of 81 is 9. So you have x to the second 9, x to the second 9. Now bring those over here. Okay, the one with a plus gets dropped. Okay. The one with a minus, you check. Is x to the second a perfect square? Yes, it is. X times x. Is 9 a perfect square? Yeah, that's 3 times 3, so that goes down. So it's x3, x3. The one with a plus gets dropped. The one with a minus we check, but x does not have a power, so that's an NA. Equals 0. Okay. Now, this x is to the first power, so one answer comes from there. This x is to the second, that will be 2 answers. This x is to the first, that's 1 answer, and that's 1 answer there. So 2x equals, let's do the one with the 2 answers first, okay? X to the second plus 9 equals 0, so we minus 9, and I get negative 9. Then I apply a square root. If you have a negative, you got to poke the eye out. And look on the board, is 9 a perfect square? Yes, it is. So I get rid of the square root. And x is positive or negative whenever you square root. 9, the square root of 9 is 3, 3i. Okay? So 3i and negative 3i. Then let's do these other ones with 1. So 2x equals 0. We just divide by 2 and we get 0. X plus 3 equals 0. You subtract 3, you get negative 3. X minus 3 equals 0. You add 3 and you get positive 3. Okay. So there's your 5 roots. So whenever you apply a square root, that's going to be the positive and the negative. And if it's a perfect square root, you write the number. Don't leave the square root. I did on the last problem because the 5 over 2 not going to work. Okay, 25x to the third power minus 100x to the second power minus 1x plus 4 equals 0. So x is to the third, so that would be 3 roots. This has 4 terms, okay? The 4 terms is the grouping, okay? So I make parentheses plus parentheses, then the lines with the GCFs out back, okay? That's what we did last lesson. And then a little parentheses times a big parentheses. And we have to do a dots check at the end. So we put 25x to the third power minus 100x to the second. Then we put negative 1x plus 4. GCF, check your final term. Is x second there? Yes, it is. Do we have a negative in front? No, we don't. 25 and 100 on the multiplication table. Here's 25, there's 100. So it'd be 25 goes with the x to the second. Okay. Is there an x there? Nope. Is there a negative there? Yes. 1 and 4 would be 1. So now I go divide by 25x squared here. And I divide by negative 1 here. So 25 divided by 25 is 1. X3 minus 2 is 1, so just put x minus 4. Those cancel, and this is also going to be 1x minus 4. So the parentheses match, so 1x minus 4 goes out here. Then I cross those out, and then I put my GCFs together to form this binomial. 25x second plus negative 1. Please write it as minus 1, okay? And then pull those over here. So we have 1x minus 4, 25x to the second minus 1. Okay. All right, there's a minus there. and take that 1 off, but x doesn't have a power, so that's NA. So we circle it and drop it. This has a minus. Now we have 25, that's a perfect square, that's 5 times 5. X to the second's a perfect square, that's x times x. So we attach an x to each of my 5's. Then 1's a perfect square because that's 1 times 1. So we make that plus minus 5x 1, 5x 1. That's a plus, it will just be dropped. That's a minus, but 5 is not a perfect square. That's a 5x before the minus. So that is an NA2. Okay. Alright, so the x's to the first, that's one answer. The x's to the first, that's one answer. The x's to the first, that's 1. That's going to be my 3. So there aren't any with 2. So x minus 4 equals 0. I add 4, and x equals 4. 5x plus 1 could equal 0. I subtract 1. 5x equals negative 1. Divide by 5. Now that's a decimal, so x equals negative 1/5. So it's just negative 1/5. And over on the other side, 5x minus 1 equals 0. We plus 1, plus 1. 5x equals 1. Divide by 5. And x would equal positive 1/5. Okay. Okay, next problem. X to the third power plus 6x to the second power minus 4x minus 24 equals 0. So x is to the third, so there's 3 roots. How many terms do I have? 1, 2, 3, 4. Now you have 4. Okay, so grouping again. Just like the last problem, I put 2 groupings back to back. So then the GCF lines come out of the parentheses. Then little parentheses times big parentheses. And a dots check at the end. So we have 1x to the third plus 6x to the second. Then we have the negative 4x minus the 24. Okay, you got x on the last term, yeah, it's to the second. Do you have a negative on your first term? No, we don't. 1 and 6 would be 1. Last term, do you have x? No, you don't. First term, do you have a negative? Yes. 4 and 24 are both in the 4th row. Okay, so we divide by 1x to the second here, and we're going to divide by negative 4 here. So it's going to be 1 with x plus 6, because those cancel. And then 1 with x plus 6. They're the same. So the 1x plus 6 is in both, so I put 1x plus 6. And then I fill out the rest with 1x to the second minus 4. Okay, so let's bring those 2 factors over here to see if we can factor them down more. Okay, the one with the plus sign gets dropped, get rid of that 1. Okay. If you have a 1 coefficient, you need to get rid of it right there. Get rid of the 1. We have a minus here, and x to the second, well, that's x times x. 4 is 2 times 2. So plus minus, we got x2, x2. Okay, so the plus gets dropped. The minus is just x to the first, so yeah. Equals 0. So I've rewritten that in factor form. Each of those x's are to the first power, so they all have one answer, but that would account for the 3 we need to find. So x plus 6 could equal 0. I subtract 6, I get negative 6. X plus 2 could equal 0. I subtract 2, I get negative 2. Then x minus 2 could equal 0. I add 2, and I get positive 2. Okay. Next problem. 18x to the 4th power plus 57x to the 3rd power minus 10x to the 2nd power equals 0. So we have 4 roots. Okay. Okay, as zeros over here, we're factoring a trinomial. So trinomials, the GCF and the T-chart. Okay, GCF, x to the second is on the last term. Check your first term, no negative. 18, 57, and 10 is just 1, okay? So there's your GCF, put it down there, and then you go up and divide by 1x to the second. 18 divided by 1 is 18. A fourth power minus a second power is a second power. Plus 57. A third power minus a second power is a first power, so it'd just be x minus 10, and those would cancel. Now, take that GCF away, we already have it down here, and then I ABC that. 18 times negative 10 is negative 180. So it's a positive times a negative, and we have to add the factors to get to positive 57. 1 and 180 is nowhere close. Divide by 2, you get 90, not even close. Divide by 3, you get 60. Aha, that's negative 57. I just got to make it positive with a plus 60 and a minus 3. Okay. Now, remember what I told you. Just set up 2 sets of parentheses. 18 is A. You drop that down, and then you split the x to the second. Splitting the x to the second would give us an XX. Okay. Then minus 3 plus 60. So you drop your coefficient and you split the x. Now these are both in row 3, so divide by 3. That'd be 6x minus 1. 18 and 60 are in row 6. 18 and 60 you would divide by 6. That would be 3x plus 10. Now bring those over here. So 6x minus 1, 3x plus 10. I don't have any 1s in front of the x's, so the coefficients stay. The plus gets dropped. Now the minus, I got a minus, but 6 is not a perfect square. Okay, so that's NA. So neither one of those can be factored into adopts. 6x minus 1 equals 0. So we're going to get 2 answers from this, 1 from this, and 1 from this, because you got a second power first. So 1x to the second equals 0. Now I don't really need to divide by 1. If I square root 0, that means just 2 of the answers are zeros. Okay. Then 3x plus 10 equals 0. You subtract 10, and you get negative 10. Divide by 3, so I'm just going to leave that as a fraction. X is negative 10 over 3. Then 6x minus 1 could equal 0. You add 1, 6x equals 1, divide by 6, so x would just equal 1 over 6, 1/6. Okay. I want to switch the next problem. Please scribble it out. You are going to switch that, please, to, get this, 162x to the 5th minus 2x. Just do it, okay? So x to the 5th, that would be 5 roots. Zeros over here, that's a binomial, 2 terms. So GCF, and then the difference of perfect squares. Okay, do we have an x on the last term in the binomial? Yes, we do. Do we have a negative on the first? No. 2 and 162, well, they're both even, so they'd be in the second row. So I bring a 2x factor down there. Now I go up and divide by 2x. So 162 divided by 2 is 81. X fifth divided by x to the first would be x to the fourth. Minus 1, and those cancel. Now, cross out the GCF. When you go to that second box, you just unclutter it, okay? Now you got a minus. Is 81 on the board? Yep, it's 9. So it's 9 times 9. Now x to the fourth is a perfect square because that's x second, x second. 1's a perfect square because that's 1 times 1. So I put 9x to the second power 1, 9x to the second power 1. Now bring those two factors over here. The one with a plus, you drop it. Okay, 9x second minus 1. Again, it's a 9, not a 1, so you have to deal with it. But 9's a perfect square, isn't it? It's 3 times 3. X to the second is xx, and then 1 is 1 times 1. So you bet that goes down into a difference of perfect squares. So 3x1, 3x1. The one with a plus gets dropped. The one with a minus, the 3 is not a perfect square, that's an NA. So that minus, oh my bad, that one gets dropped. 3x minus 1 equals 0. So the x's to the first, that's one answer. X's to the second, that's 2. X's to the first 1, and then x's to the first 1. Do the one with 2 first, that's a hard one. So I subtract 1, I get negative 1. Then we divide by 9. So x to the second equals negative 1/9, but now you got to do square root to eliminate your second power. So I bring the I out, okay? Now, I'm going to get rid of the square root because if you look on 1 and 9 are both numbers we can square root. The square root of 1's 1, the square root of 9's 3. We put the I right there, but it's the positive and the negative. So 1/3 I, negative 1/3 I. Then, let's do the other ones. 2x equals 0. That's easy. We just divide by 2. We get 0. 3x plus 1 equals 0. We'll subtract 1. We get negative 1. Divided by 3. And you get negative 1. X equals negative 1/3. We don't have to square root these because there's no second power. Then 3x minus 1 equals 0. So we add 1, 3x equals 1, divide by 3, x would be 1/3. So that's 5 roots right there. 1/3 I, negative 1/3 I, 0, negative 1/3, positive 1/3. Okay. Last problem, 2x to the 5th power minus 28x to the 3rd power plus 90x equals 0. So x is to the 5th, so there are 5 roots. And you got a 3-term trinomial, so that's GCF, and then the table. Okay, do you have x on the last term? You do. You have a negative in front? No, you don't. 2, 28, and 90 are 2. Okay. Okay, so let's divide by 2x. 2 divided by 2 is 1. X 5 minus 5th power minus a 1st power is a 4th power. 14. 3rd power minus a 1st power is a 2nd power. Plus 45, and then those cancel. Oh, sorry, you got to remember to put your 2x right there. Now, cross out the 2x, and this is the trinomial we're trying to factor now. A, B, C. So 1 times 45 is 45. It's positive, so it's a negative negative. You're adding to try to get to negative 14. 1 and 45, no. 2's a decimal, 3's a decimal, 4's a decimal. Or no, 3's not a decimal, it's 3/15, but that's not it. That's negative 18. 4's a decimal. If you divide by 5, you get 9 right there. Okay? Now, make 2 sets of parentheses. Okay? Now, the leading coefficient's a 1. So I don't drop a 1. When it's 1, I get rid of it, and I split the power. X second, and then minus 5, minus 9. So we don't really need these then, okay, because I can't reduce that. So on your dots check, x to the second minus 5, x to the second minus 9. Now they both have minuses, and that's a perfect square, but the 5 isn't, NA. So you drop x to the second minus 5. That's a minus. X to the second's a perfect square because that's x times x. 9 is 3 times 3, so that's going down. x3, x3. The plus is dropped. We know that's prime. The minus is also prime because x has no power. So one answer comes from this because it's x to the first. That's a second power. The 2 come from there. 1 and 1. Do the one with 2 first. X to the second minus 5 equals 0. So I add 5. X to the second equals 5. Then I square root 5. Now I don't need to poke the eye out because it's positive 5. Okay? 5's not a perfect square, so we're just going to leave the square root over the 5, but it could be the positive or the negative. So square root of 5, and then the same thing with a negative. Okay? Then 2x could equal 0. We just divide by 2, and we get 0. X plus 3 could equal 0. We subtract 3, and we get negative 3. X minus 3 equals 0. We add 3, and that's positive 3. 5 roots.